You're all able to hear my voice and see my screen, right? I've started sharing my screen now. So just let me know in the chat if everything is good. Hello. Okay. Awesome. Thanks. Awesome. So let's get started. So today, let us talk about tagged template literals and why they are very important for the community. And just to give you some background info on how tagged template literals work and how you can use them in popular libraries. So, for example, popular libraries like style components, emotion, etc. Um, they use tag template literals extensively, and the whole library is based on that. So, it's very important for us to understand how it works. So, I'm Bhargav. I'm a senior front end engineer at a startup in US, and I work from India remotely. And other than running this meetup, I also write books and blog posts on React.js. I also teach students on Code Mentor and so on. So recently, my interests are basically in XState, frame of motion, and yeah, mostly XState and frame of motion. So if I'm not talking about React, I'm probably talking about XState or frame of motion. Both are amazing libraries, and I think you should be checking them out. So let's get started. So tag template literals, how do they look like? So they look like something like this. So you have a value, and that value is created uh, by doing something with a couple of backticks. So there are multiple ways in which you can use these backticks. We'll discuss all of them, but the most basic form of it is how you can concatenate two strings or a string with multiple objects. For example, if I want to actually, let me just start Coca here. So I have value one, which is hello, and two is world. I can join. I can create a new value by concatenating um, value 1 and value 2. Now my value is basically hello world. So yeah, this is just an extension that I'm using. So it just prints the output, the value of that variable, just to the right, so that it's easy to give a demo. Okay. So what else can you do? So not only can you concatenate strings. So the original way of concatenating strings is something like this: value 1 plus, and join, put a space if you want, and then value 2. So the original string concatenation before ES6 came about was by using the plus operator. One sec. Yeah. Right. Uh, so this notation is just a newer form of doing it. But not only that, it also makes it very easy to join even numbers also. So for example, if you have a number like this, const num1 equals 5, then when you do this, when you add a number to the string, it is implicitly converted to a string. So now str will automatically concatenate it as a string to the existing, the string beforehand. So the conversion is implicit. Right. The same thing happens with tag template literals also. You can also concatenate them. However, there's a difference. We'll talk about that shortly. So if I have to create a tag template literal with strings and numbers, you can do the same thing. You can just wrap every value or variable that you have within your a dollar and braces, and just put the value, and then the same thing with numbers as well. You can do the same thing. It will be the same thing. Hello world 5, right? Pretty very similar to to plain string concatenation, except that the syntax is more easier. You can just, whenever you want a space, you can just put in a space here, and just whenever, if you want some text to add here, so for example, hello this world or something like that, then you can simply type in the text here, and so it just feels very easy to concatenate strings with this method. So the thing here is that tag template literals, this backtick notation here, wasn't just made for concatenating strings. It is so much more. It gives you a ton of behavior, and we are going to talk about all of that today. Okay, so tag template literals, the original behavior of tag template literals is by using functions. So tag template literals are basically how you use functions to interpolate strings. So what exactly is interpolation? Interpolation is mixing of values. Interpolation stand. So the definition of the word interpolation is that you are mixing different kinds of values. So in our case, we are interpolating strings with other values like objects, numbers, even functions, and so much more. You can put in various values within your tag template literal. So for example, I can create another variable called b, and not only can I add value 1 and value 2, but I can also put in a function if I want. Function, except the default behavior just stringifies the function. But so but this is just the beginning. So so this default notation is going to stringify a function, but the original notation of this is that what you can do with tag template literals is that you can use any function with the tag template literal syntax. So for example, let us start a simple function that looks like this, function hello, and let's log the arguments. Log arguments, or we can grab the arguments from .args, right? We can do this. Okay, so now if I call hello with world, it is showing me world here. The argument is an array of all the values that we have passed. We have only passed one value here. We can pass more values to it if we want, Bhargav, etc. So this is just hand information to see how the args are looking like. Okay, we can also call this function by using tag template literals. So to concatenate multiple strings, what we did something like this. We put some strings here and then some values and so on. But we can also use the same notation to call functions also. So the function, to call a function with tag template literals, we need to do hello, couple of backticks, and then we can pass in world. So this syntax is very new. If you have not used style components or CSS and JS libraries like Emotion or Glamour, then this syntax is probably new to you. But until now, we have seen this. We have just seen how you can concatenate values like this, right? We haven't seen this yet. This is a newer syntax. This is the original tag template literal syntax. So what you were seeing with this is that there was a default function here, some default internal function in JavaScript, which we'll talk about. But the actual, what is happening behind the scenes is that tag template literals is always called with a function, and if you don't call it with the function, then an implicit function is used. We'll discuss that also. So the original syntax, again, let's get back to that. The original syntax is by using a function, and instead of calling a function with brackets and putting the world and passing in arguments within the brackets, we use backticks and pass a string to it. Not just a string which you can interpolate with values. So for example, actually let's just start with this simple string as argument. So I'm going to remove this. What we are seeing here is that args is actually an array of values, and the first item in the array is actually another array which has the text world. So let's grab that. So I'm going to call this array as strings. Now let's look at what strings is. Strings is an array of world. So now, for now, I'm just going to return world. Return strings of 0. Okay. So now hello world should give me world, right? Or I can just customize this behavior by again hello or something like that, and world. I welcome whatever. I can customize this as I want. Okay. Now the strings is basically all the how can I put it? So for example, if I type in hi, how are you or something like this, then strings it does not really split it. It just gives you the entire blob of string. But if I put in a value here, so for example, if I create a value called const var equals const number equals 5, and if I put in that number here, now what has happened is that it gave me two strings. Of course, the number is missing, and now the output here again is hi, welcome to whatever. Okay, let's remove this. Output something like this. So it's going to give me output hi, how are you, but the number is gone. So let me put something else over here. Um, Come to full stack. Okay, so we only took the first value. We completely disregarded this. So let's actually use that also. So how can we just compute? How can we join these two? There is a very easy way of doing it. What we can do is we can create a new string. Const output string is strings dot join spaces. Now output string is basically just the strings array joined by space. So hi, how are you? Space, welcome to Fullstack Javascript. That's what we're seeing here. And instead of passing strings of 0, I'll pass output string. Okay, so now let's look at the output. Output, hi, how are you? Welcome to Fullstack JavaScript. Everything is good except that this number is gone. We're not using the number anymore. So how do we access this number? So to access this number, we can, the second argument that is passed to tag template literals is all the values that have been interpolated in that order. So we have only interpolated one value. So that one value will be here. So I can grab that here, so number. And so while joining, if I want, what I can do is I can do strings of 0. So this is a very primitive way of doing it. There is a much better way which I'll show also. Strings plus space, then plus number plus more space, and then strings of 1. Okay, so let's remove this now. Now what do we have? Okay, the number is back now. So this is what the default function is. So the default function basically just uh, puts the first string and then the first argument. Then if there are more values, right? If we interpolated multiple values, so let us say we have something else here, number 2 or something. Number 2 equals 10. Then I can grab number 2 here, and followed by strings of 1. I need to add in space is just something that I am adding. I don't need to add space. Then number, and then followed by strings of 2. Okay, so output hi, how are you, and so on. So what we managed to do is we managed to create a function that replicates the default behavior of tag template literal. So for example, if I simply just did this, then both the values here are the same. Really? It is, no? Mm. Hmm. What happened here? Run in browser. Probably some issue with Coca, right? That's what I think. Yeah, because the function is definitely defined. Hello of this is not a function. So yeah, okay, maybe maybe it's trying to run this also. Yeah, I think Coca is causing weird issues. Let's try again. Hmm. Number 2 is defined, right? Okay, I'll run in the browser. Okay, I hope you are able to see this. Okay. Yeah, so I'll just remove all of the stuff before this. Just have hello and this. But why? Cannot access number 2 before initialization? How come? Can you see, is there a problem here? Because number 2 is definitely defined here. And I'm accessing it here. How is it not defined? Yeah, I'll just use var or something. Okay, I'll do that. I don't mind doing it, but number 2 should be, I mean, I'm using number 2 from the argument, right? So it should be defined. Log args arguments. Let's do this. Args, and the first argument is strings, and then rest equals args. I have both, right? So I have 5 and 2. Okay, let's grab it from here. Number 1, 2 equals rest. Because number 2 is an argument from here. Why does it? Anyway, so some issue with. Uh, yeah, but I'm not hosting this, no? I've defined it here. What is the problem? So that is the thing. Anyway, let's get back. So I'm just going to move it over here. Maybe I'm missing some some concept or whatever, but as far as I know, there is no issue with the code. Um, but okay, let's get back to it. So Coca is still working, so that's good. Okay, yeah. So what we did here is we managed to create a function. So I'm going to change this to default TTL default tag template literal, and we are getting the same output. So this and this they are performing similarly, except I added output here. I don't need to do that. For the same, we managed to make a tag template literal that works exactly like this. So again, to do a small recap, so this is actually internally by JavaScript, it is passed through a default behavior for tag template literals, and that looks something like this. However, there's a problem here. We are limiting ourselves to two values. We are expecting that there are only two interpolations inside a string, but that's not always the case, right? That's not always the case. So we need to have a function, or we need to have a behavior that will interpolate no matter how many arguments we have, how many interpolations we have. So it's like one string, then so the first part of the string. So how are the tag template literal split? So it is splitting. It is passing the strings as an array of all the parts of the string parts, and then also the interpolated value separately. So hi, how are you is one part. So the first item in the strings array is hi, how are you until this part, and then this is left out, and then from here is the second part. So strings, the second value in strings is welcome to, right? and you get the idea, right? So it's splitting them in such a way that it is sending the string parts and the interpolated parts separately. So that is the important difference between calling a function uh, with tag template literals and calling it with if I called it like this, let us say I called it like by this. So then what happens is that let me show you. Okay, I'll just explain. So what happens is that if you call it with the original function notation, this value is computed here. So before it is even passed to the default to the function, this value is computed here itself. So all the numbers are computed here itself. So if what happens is that if you pass in a function here, then that function is converted to a string here itself, and you can't use it over here inside the function body, inside the tag template literal body. So I'll show an example shortly. So the reason why tag template literals are preferred is that it automatically splits you into strings and variables in parts. So now let us write a small function that helps us to concatenate as many string parts and arguments that the template literal function receives. So to do that, what we'll do is we'll use a function called we'll use a method on arrays called reduce. So reduce simply takes each value the array and it performs an operation and keeps remembering the output. So the way it works is that let us say you have an array of have fruits equals one. And what I can do is if I want to join all of them, I can simply do fruits.reduce. So the reduce method takes an argument, and the first argument that it takes is a function, and it will initially start with an output value, and the initial output value is string. I'm starting with an empty string. What I want to do is I want to go to each item and add it to my output string. So I'm going to call this output, and then the reduce function calls the callback with the current value of the output and the current index, that the current item that it is looking at. So item and then item index. Very similar to map. So this part is very similar to map and for each. You're probably already using it. So what we need to do is we need to grab the output at that point and just add item to it. Const output. Okay, it has joined all the three values in the array. So we'll use the same logic here. So what we'll do here is instead of doing this, what I'll do is I know that the number of items in the strings is always greater than the number of is greater by 1, right? If there are 2 interpolations, then I'll have 3 parts in strings, right? So even if the interpolated value is over here, even if I interpolate this value here, something here, some dollar number, and even then I'll still receive a blank string at the end. So it's like if I have n interpolations, I'll have n plus 1 string parts and n interpolations that I can grab from the argument. So I know that I have that information. I'm going to use that. And what I'll do is I'll create output string like this. Output string is strings dot reduce, and I have the output value. So I'm going to start with an initial value of string in the same way that we did with the fruits array. And the second argument here is the current string that I'm at, and I also have the string index. Now what I'll do is I'll simply return output plus string plus I have the index, right? So after getting the first string, and I'll need to put in the first interpolated value. So I can simply grab that from rest. I'll no longer do this. So rest will contain all the interpolations that we did, 1, 2, 3, right? So there are 4 parts, there are 3 interpolations. I'll simply grab rest of string index. There is a chance that it does not exist because when string index reaches 3, there is no value here. So in that case, I'll simply just put in a blank string. Okay, so now let's take a look. Const output equals, okay, hi, how are you? Hi, welcome, and so on. This is exactly the default behavior of tag template literals. So I just wanted to show that here. So if you have to create a tag template literal function that looks exactly like this, exactly like the original, the internal behavior of a tag template literal, then this is how you would do it. Okay, so we can take this a step further. So for example, whenever there is a, I want to create a very hyper imaginative use case where, um, so when I pass in a number, I want to wait for that many seconds. I can do that. So where really imaginative use case. Here I'll receive my arguments. I'll grab all of this. But if it so happens that I receive a function as argument, or if I receive a number as argument or whatever, if I receive, we do this. No, I don't have to do this. Const wait, let wait time equals 0. So if what I can do is if type of rest of string index is a number, then I don't want to concatenate it. Let's add it to output, and I'll just add this to wait time. So wait time s equals rest of string index. Okay, if it is not a number, then I'm going to do this. Okay, so now what I can do is I can do highly imaginative use case of hello, and I'm going to interpret a number here. So maybe 1, 2, whatever. Let's take a look at the value. The value is hello. The 2 is gone because we are not taking a look at it. But if you want to wait, what I can do is I can create an async function out of this. I can create an async function, and here, once I get the wait, before outputting the value, I can wait. So set timeout. So you don't have to, it's fine if you don't understand the syntax, but I'm just creating a fake promise here. Set timeout, wait time star 1000. Wait new promise resolve. I want this promise to resolve after some time, and it resolves after, this wait time is completed. So let's log the wait time just in case. Console.log wait time. Okay. Yeah, so what this will return is it will return a promise. So it's fine. I'll just log the value here. Console.log output string. I still have a browser tab open. So okay, it waited. It's a stupid use case, but I wanted to show you that because now you have access to the internal behavior of how you can concatenate strings. It means that you can do all sort of stuff with it. You can even do async await stuff with your tag template literals, and that is exactly what libraries like style components are doing. So the last thing that I want to show here is, I think I have 5 more minutes, so let me show that also. So let me get rid of all of this, and so this is how style components looks like. So what they do is, within the interpolation, they accept functions as arguments, and what they do is, based on the, so when you pass functions as interpolations, they have a different behavior. So here in our use case, we saw that if we find a number, then we do something weird. In the same case here, what you can do is you can look for a function. If you find a function, then you wait or async, or you can interact with the style sheet if you want. Whenever you find, array, yaar, what is this mail app, man? Who made this? Yeah. So whenever you find a function, you can either interact with the style sheet, like how style components is doing it, or you can perform computations if you want. But I have one last snippet that I want to show you, which is um, one sec. Yeah. So what we'll do is we'll create a higher order function with tag template literals. So it looks something like this. So this is a function. This is a tag template literal that it has the same syntax. It grabs the strings and interpolations, and instead of just returning the value there itself, it is creating a greeting. It is creating a function that can be called again. So it looks. So if I want to create different kinds of greetings, I'll use it simply like this. Now I created a greeting called hello, and it has. I'm passing a function here. So this syntax is a function, right? This is a inline lambda function in JavaScript. And whenever I find a function, instead of just instead of just returning that function and converting it into a string, I'm sort of executing that function with the parameter that it has received. So because this function is received, so when I call this function with a value, so if I call hello with Bhargav or something, then this argument is passed over here as name, and I'm simply executing that here and creating a new value. So I'm just reusing the same variable here, but you can use different variables if you want. So if it is a function, then I'm executing that function. Otherwise, I'm simply joining it to the string that I'm already using. I'm calling it accumulator or accumulator output, whatever, same thing. So I can create new greetings from this. So what's up and hi, what's up, and if I do Anil, hi Anil, what's up. Okay, I hope this is clear. If you have any questions, just keep letting me know. And this is just again another use case. So sometimes I don't want to even use the argument, but what I did was if I use a function, it will be called with name. I can simply ignore that name and just do something else here. I'm grabbing the current date, getting full UTC year, and so on. Okay. And finally, the last use case is how you can use this to create classes or to create classes of objects. So this is the ultimate form, and this is how style components is also doing it. So with a tag template literal, if you can create a function, if you can create a class out of it or an object out of it, then your use cases, then you can cover more use cases than before. So this is one example that I want to show. So call it create species. Okay. So I want to create a new species, and I want to create a dog. So to do that, I can set const dog equals create species of here what I'm doing is I'm simply creating a function called greet. I'm passing that to my species object as argument. So now whenever I call dog dot greet, I get boof. Same thing with if I want cat or whatever. Okay. I hope this was useful. This was a small introduction to tag template literals, but I think this is a very powerful concept. And if you want to create new libraries out of if you have new libraries in mind, maybe tag template literals might be very useful for you. So thank you very much. And Anil is now going to talk about browser extensions. So I'm going to hand it over to him. I'm going to stop my I'm going to go backstage now. Also, yeah, sorry, if you have any questions, just let me know in the chat. I'm happy to take them. Okay, you are ready now. Okay.
Okay. Can you all hear me, actually? Okay, cool. I believe you can share the screen. You can see my screen, right? Cool. Thanks. So, yeah. Hi, my name is Anvesh, and I work as a web developer at Exactly Corp. And this is my talk, and it is regarding ECMAScript modules under the hood. So, before we jump into this talk, this is my first talk, and this presentation is an oversimplified version of the the popular blog article written by Lynn Clark, and yeah, I'll try to explain some of the concepts, how ESM works internally, and how JavaScript engines and the web browsers work in tandem with each other to deliver this feature. Cool. So before I jump in, just making sure that everyone can see my presentation. So I believe most of us would be using this ECMAScript modules probably for the last couple of years, and you might have used it for a million times already. So, but this will be a quick refresher of the features. So here is the two types of declarations. One is the CommonJS format, which you might have noticed in the Node.js while working with it, or probably if you have been a web developer for quite some time now, you might have noticed a require based syntax in previous in your previous past code bases, right? So, and the next one is ESM. Sorry, and this syntax is called as the CommonJS syntax. And the next one in the line is the ESM syntax, which is the ECMAScript modules. And this is the popular format, and which was introduced by the ECMAScript team. Yeah. And yeah, prior to ESM, most of us would have been using some of the module patterns. And this is a very popular module pattern called IFI, immediately invoked function expression, as you can see here. And we would wrap this function in a self-invoked expression, and we would execute a code here. And yeah, this is a very popular format even today. And this is another module pattern, which is also a popular one. And this is called a revealing module pattern, where one would create a module and then blah blah blah, and there's a lot of code around, and then exposed members are returned as an object, and then once invoked, you can create objects and you can make code accordingly. So these are all IFI and revealing module patterns are the popular ones. So I've covered these in this talk. And a little intro, why do we need to talk about this, and why those module formats are important for a dev to know. As you can see here, initially the CommonJS format was the original inspiration for all the formats that we see today, and the pros and cons of all the previous approaches have been improved on, and maybe more features have been added in ESM. As you can see on the far left is the CommonJS format, which first evolved, and then we have asynchronous module definition, which is targeted for the browsers, where one can download modules and then execute them and then run them in the browsers asynchronously. And then we have a UMD spec. UMD spec can be thought of as a broad version of as a AMD and a system.register and then CommonJS modules all wrapped under a single umbrella. And then later we have ESM, ECMAScript modules. So yeah, moving on to the next slide. So in my talk, I would try to cover some of the topics on the ESM and CJS. And by end of this talk, I believe you might learn some concepts of ESM in comparison with the CommonJS modules, and then some of the patterns and the usage wherever possible. And then you can apply them in your production code or probably improve your understanding based on the conversation in this talk. Yeah, so the ECMAScript modules are supported by all major browsers, barring Internet Explorer, and they're available in all the browsers without any flags, experimental or any other flags. And then the support for ECMAScript modules had existed in Node.js, I believe from like 9 or 10th version, but with experimental flags. However, from 13.9, it was available without any flags, and it's now much more robust compared to the previous versions. And efficient. It's efficient because a lot of these ECMAScript modules, what we execute on the browser, are done asynchronously. So thereby, utilizing the time, the CPU cycles in the browser. And then there is only one module per file in ECMAScript module. However, the case with the CJS modules, we can throw 1,000 or maybe 100, whatever number in one single and still get executed in the browser. That is one difference, a big difference in compared to CommonJS and the ECMAScript modules. And the code is always run in the strict mode in the ECMAScript modules. Yeah, and one of the strong features is the modularity and reusability of the code. So yeah, as a result, a modular code written can be used across multiple projects, probably in some sort of a common shared code base where all the JavaScript based projects can access the code and reuse it. And then it's portable too, and I believe with sufficient permission and coarse permissions, one can access a modules defined in a different projects or in a different domains, and then include it in different applications as well. And ESM broadly has many phases, and we can think of it as like three main phases. One is the construction, instantiation, and evaluation phase, and we will discuss in detail in the coming slides of each and every phase. But I think we can begin with the construction phase. So construction phase has got three sub parts. One is the module resolution, and the fetch phase, and the parse phase. So talking about module resolution. So as you can see, just a pointer. This is a static module, what you see here. The reason I say static module is because all these code, whatever that's you can see in the code screen, is actually parsed and evaluated, and then later it is executed. you can see here the vegetables slash tomato .js in the first import statement. So this is how one would access within a file system, and the next line, import vegetables from vegetables, and this is how you would one would access within a bundler environment. So the reason why the second line is looks seamless, as if the vegetables is as if the string vegetables is available across the platform, is because of bundlers like Webpack and Rollup. They make it easy. They keep the references to a particular module if installed via an npm. So instead of giving a path, we can directly mention it as an export using the keywords actually. And the thing is, in the module resolution, the ECMAScript modules, or which internally the JS engines implement, have to follow some rules for resolving modules. As you can notice, there is the file path vegetable slash tomato JS. So this is called as a module specifier. So in static module resolution, what happens is these files have to be present even at the time the file gets downloaded into the browser. So as a result, there are certain pros and cons in this approach as well. We'll talk more about in the next slides. And you can notice here in the second slide is the dynamic modules. In the dynamic module resolution, where one can call and access, call and download various modules at runtime. So I believe most of the devs might have already used such features. And here is one example where one can download modules on the fly based on certain conditions and all, etc. And this is called as a dynamic module. Just to repeat, the string inside import or the string after the from is called as a module specifier. So this module specifier has got certain rules and restrictions, and the way how JS engine interprets it and how it evaluates it is different. Yeah, and as you can notice, module resolution in browser and server environments will happen as per the module resolution algorithms defined. So this module resolution algorithm is as per the spec of as defined in the HTML specification standard. So any browser that implements this standard should conform to this resolution methodology. So there are two types. One is static module resolution and the dynamic module resolution, as we covered in the previous slides. And one of the important things that one should remember is going forward in the next slides is module map and the dependency graph. One can think of the module map as a key value pair, as an oversimplified version of a key value pair, and the dependency graph as a normal graph, which contains dependencies and the lookups between all the dependencies. So in this module resolution phase, so this is a construction phase, and within the construction phase, we are in the module resolution phase. So in this phase, both the module map and the dependency graph are created. Not just created, as and when the new modules are encountered, they are updated. This module map and dependency graph are updated accordingly. So another topic to cover is the module loader. So we might have wondered when someone says import tomato from /vegetable/tomato JS, how would the browser understand it? How would the JS engine interpret it? And this is where the module loader comes into picture. So module loaders, usually JS engines don't deal with how a module should be fetched from the internet. It's totally beyond the scope of the JS engine. This is done by the HTML loader. So loading from particular URL or from a particular path of the JS asset or any other etc. Will be done by entities called as module loaders. These module loaders are implemented by the web browsers, and each browser has its own algorithm for loading of modules. Okay, before jumping more in, we'll cover some of the other aspects of this. So this module loader and our vendor specific implementation, as I just mentioned, and then just to recap, a module map is created, and as with all the key value pairs, where one can think of the key value pairs as the module specifier being the key and the value being the current state of the module. And and there is only one module entry in the module map. So as I said, each URL that you access or each file path that we access in the import statement, it becomes a key. The module specifier becomes a key. Once it's a key, no duplicate entities will be allowed, and any other references would be accessed for the same key value pair. One can think of the module map like this. As you can see the screen here, it's on the left side, it's the file path where I'm trying to access the URL, and then on the right side is the state of the module specifier. As you can see here, we are trying to access three different types of module specifiers: the vegetables.js, fruits.js, and cookies.js, and the current states. And you can see, I'll explain more about the states in the coming slides, but here, and the reason, the advantage of this module map is that we can avoid making duplicate requests. Let's say we have like multiple files and each accesses the same vegetables.js. So instead of making multiple API calls, the browser would cache all these requests and then would make only one API request or module request. And all of that is maintained in the module map, actually. And it gives us the better tracking of modules across the entire application. No matter, even if there are 1,000 files or like 500 files or 10 files, there is no duplicacy. So if it's in the module, it will be in the entry would be created in the module map. And then this also improves the sharing of modules, because and let's say if one is using a dynamic imports, so if the module is already available, it would be looked up from the module map and served instead of fetching it from the fetching it on the fly. And then error handling, we'll talk about it eventually. Yeah. And next thing is module map is updated as and when the new module is discovered, right? And here are the list of all possible states a module resolution happens, actually. So one is the fetching, which means it's whether if it's currently being downloaded or not, and null indicates an error. And as and when there is an error, even the error values and the error stack trace will also be cached in the module map. And then there is something called as a module record, and we'll discuss about it in the next slides. But for now, you can think of module record as a data structure that holds the current state of a ECMAScript module. And then there is instance, where a module record after evaluation, after instantiation, an instance is created, and then it's updated back in the module map. So here is a rough example of how a dependency graph would look like. So imagine the index.js file has got multiple subfiles like vegetables.js and fruits.js, and a lot of other files like grape.js, tomato.js, banana.js, and different things. So this is how it would maintain a graph of all the modules which are declared, which have been defined in the files. So it maintains a graph, and it knows how to look it up and how to access different values and how to traverse between them. So, just to recall, this dependency graph is created during the module during the construction phase. But however, not the entire graph would be populated, because a lot of these modules would be downloaded on the fly. Sometimes on the fly, or sometimes it takes a while. Let's say it's a huge code. Let's say in case of a huge code base, a lot of modules are there, and then the JS engine makes does a depth first traversal, and then it creates a graph, and then also creates corresponding entries in the module map, and then it keeps on updating it periodically. Yeah. Now is the next phase in the after the modularization. The next phase is the fetch. This fetching is done by module loaders, which are vendor specific implementations of the ECMAScript HTML specification standard loader standards. So each browser has got its own way of downloading content from the internet, and yeah, and they have their own strategies for optimizing using HTTP 1.1 or 2, or probably to accommodate different fetch, prefetch, preload, and all those various conditions actually. And uh, and one important point should be remembered is that all of these phases, the construction, evaluation, and construction, instantiation, and evaluation phases, all happen asynchronously to avoid wasting CPU cycles. So even loading of the modules happens in asynchronous actually. We'll talk about it in the next slides. So during the parse phase, so after fetch is the parse. This is the final phase in the construction. It is a final sub phase in the construction phase. So this is where a module record is created. As I mentioned, a module record is like something like a data structure which holds the state of the module. So it usually contains the code that you have written in your module, the module code that you have written, and also the import and export namespaces. So the import entries and the export name entries, the names, the specifier strings, the module specifier strings, the namespaces of the import entries and the export entries, and a lot of custom properties and methods. And even browser puts in the browser puts a lot of custom related stuff here. Yeah. And an important point to note is that module resolution, fetching, and parsing all will happen asynchronously as and when a module is encountered. So as you can see here, illustrative representation that in a module map, different phases of these module specifiers here. One, you can see the vegetables.js where the module record has already been created, where for the fruits.js probably it's still in the fetching phase, and for the cookies.js the module record has been already created. So this is to help to help you guys understand that it happens asynchronously. So what happens in instantiation phase is that yeah sorry so what happens in instantiation phase is that all the memory allocations for the module records happens, and then the JS engine keeps a record in the module maps, and then it also creates corresponding dependency graphs entries for the corresponding modules. So how was the dependency graph created? So as you noticed, the module will have import and export entries. So import export entries are the wiring joints where different module records are actually connected, how they'll be connected. So as and when this completes, the module record is instantiated and updated in the module map, and this is called the module instance. So there are two things. One is called as a module record, and one is a module instance. So module instance happens when the dependency graph entries are added, and then the module map is created, entry is created, and after that module record should have already been created. And once all of this is done, and the wiring happens, and then the module just a second, and then the module instance is created. So these module records are wired based on the export and import declaration, as just mentioned. So, and these module instances will be accessed across all the modules. So as I said, there will not be any duplicate fetching. There will not be any duplicate evaluation of the code. This is happening because they all share the same instance. So that is the reason it's much more efficient than compared to common JS. And this is also called as a live bindings, because all these module references, import and export references, use the same use the same memory, and then they all communicate using the module instances. And because of this reason, I believe a lot of you might have used some variable values, and even after updating it, it is possible to access the values in the new modules. So this is called as a live bindings. So it behaves like a singleton. So that's where many people, I mean, you might have read in the blog saying that ES modules behave like a singletons, or probably are singletons. So that's what people say. So that behavior is possible because of the feature called as live bindings. So after instantiation, this is how it looks like. So we can see on the left side, the keys are the module specifiers, and the right side is the module instances. So you can think of this module instances like this. So you can see in the stack in the middle, where all your code is there and all your import statements are being referenced. So you can see all the imports are wired, and different module records for different modules are there, and then a function when accesses it, they are referenced to these module records. And during instantiation phase, the JavaScript code is not executed, and it is executed only in the evaluation phase only. And as I said, it behaves as a singletons, and even if the value is changed, it can still be accessed by all other modules wherever the import reference still do exist. And yeah. And then the evaluation phase is where the execution happens. All the memory allocations for your JavaScript code happens, and then and all the import export values. When I say import export values, is actually this, the import tomato. The tomato is actually a namespace which can actually refer to a particular entity from a particular module. So all these things for all memory allocations happen, and once the memory allocations happen and the values are actually filled in the evaluation phase. What do I mean by filling of values? So when before hitting I mean, in order to use tomato, it should actually go and look up the module reference, the module specifier that that's being imported from, and then the values will be placed within the module record of that particular file. So yes, and after the module is executed, its current state, whether if it returns an object or if it returns a function, it's actually placed in a particular format, and it's placed within the module map, and then it's accessible within the module map. And the module is executed only once in the entire lifetime of an application. And in case of errors, it's updated in the module map, and then even if another module tries to access it, the error is returned. It will not get executed again. And modules are always evaluated in a strict mode. So the main differences is like in CommonJS compared to ESM is like, in CommonJS, all the fetching, parsing, and execution all happen in sequence, and as a result, there's a lot of wait time for the modules get executed, and it takes and it's comparatively very slow, and a lot of CPU time gets wasted here. And with the ESM, all these things are broken down into independent parts and with asynchronous behavior. And in CommonJS, if a module exports a value, it is actually copied into an object, and then it's shared. So even if a value is shared, is changed within that module, it will still not be accessible across the other importing modules. And some of the things which you can remember is like the dynamic module specifiers is not possible actually. It is because of the Yeah, it's because during the construction, instantiation, evaluation phases, as I said, memory allocations happen, but the values are not copied it. So because the values are not copied, for example, in this case, the dollar path is still not available during those phases. As a result, it throws up an error. So such things are not possible. But I think there is a certain proposal to introduce a concept of macros where one can do certain dynamic variables, and one can use certain dynamic variables and things like that. But that still is in a proposal, and it's not approved yet in the TC39 committee. And that's it about this talk. And I believe it's a short talk. And yeah, thank you.
Awesome, man. This was very good. So we ran a poll, if in case you haven't seen. So our poll was that
Sorry.
will model bundler work with files other than fruits and vegetables? So all the file names that we shared were what? Fruits, banana, apple, and cookies. Awesome, man. This is very good. So I have one question. So the question is that in the traversal, how is CommonJS and ESM the same in terms of traversal? Depth first, right? Both are depth
Yes.
first, right?
It is depth first, but the thing is, in CommonJS, in CommonJS, it's based on a key value pair specification that we give initially. So the module first that is defined, and its internal dependencies will be changed. So that can be changed, and the order can be changed dynamically as well. But in the modules, you can't change it dynamically. That is one part. It may be depth first, but it can't be changed dynamically, is what I'm trying to say.
Okay.
Did I confuse it? Sorry.
No. I think that was clear. Another question. So guys, everyone, do you, if you all have any questions, just let me know in the chat. Yeah. Also regarding the dynamic aspect of importing with ESM. So I believe that the current state is that as long as you specify the folder within which all the imports are there. So
Yes.
that is, I think it is now possible. So perhaps Webpack or Rollup, they're able to do that. Dynamic
Yeah,
imports are
they're able to
handled.
do that because of module bundler, because they're behind a module bundler actually.
Yeah. Okay. Mm-hmm. Awesome. So Anil is asking how is Rollup and Webpack, how are they different in terms of bundling?
Webpack uses Torso and some internal stuff to pack bundles.
You can speak, no? You can speak and then you can type. Yeah.
Oh, sorry. Okay. So Webpack uses Webpack uses Torso and some internal stuff to pack the bundles actually, and the way how it does is actually a bit different. I'm not sure about how Rollup does, but every development team takes a different approach at it actually. So yeah. Or do you have anything more specific to ask on in terms of how the bundle, Anil? Probably I can try answering it if I know. Okay.
Yeah. So is live binding optional, or I mean, it's not optional,
No,
right? I mean, you can't.
it's not optional. It's
Yeah.
it's a ECMAScript standard specific.
Standard. Okay. Yeah.
So
That's
because the share module, it's really faster actually.
Okay. Awesome, man. Thank you very much, Anvesh. This was very good. So this is his first talk. So please, give him applause. Lot of applause. So the smiley button, there is a smiley button at the bottom. Spam it and let him know. Awesome, man. Thank you, Anvesh. Next talk will be Anil. So Anil was supposed to speak earlier. He had some mic issues. So let's try Anil again. I'm going to end this.